Normally, in a tutorial about effect plugins, you would expect to look at what effects are available to process your sounds. However, because of the way of which the various modulators, controls, and MIDI parameters can be used in Nitrous to change those effects, it is important that we take a good look at how these work. The matrix is the glue of Nitrous that is used to tie everything together, so let's take a look at that first. The key to flexibility of Nitrous is the way in which the matrix is able to map a modulator, control, or MIDI message to a large selection of parameters, taking not just from Nitrous effects, but also from the various mix functions that are available. It is even possible to map one of the controls to another modulator parameter, allowing you to modulate the modulation. For some of you, this may sound quite complex. However, once you get the hang of how all this works, it is actually quite easy to use. In total, you have 16 slots available to you. Put simply, the left-hand side of the matrix is used to select which particular control you want to use. And the right-hand side is used to choose what parameter that you want to control, or to affect. The sensitivity control in the middle is the percentage strength the control has over the parameter. Note that the sensitivity is bipolar. It has a range from -100 to +100. This allows you to have a control that increases in value that results from a negative change on its target parameter and vice versa. You can have up to 4 modulators active at any time within one instance of Nitrous. You can access each of these by clicking on any of the mod's 1 to 4 buttons that you see in the upper section of the interface. It is worth noting that this mirrors the operator buttons on the right-hand side. To insert a modulator, you can call up the drop-down menu by clicking here, giving you the option of a number of different modulator types. The arrow on either side allows you to cycle through these types as well. Let's take a closer look at the low-frequency oscillator first. In this patch, we already have a pitch shifter effect set up. What we aim to do is to use the low-frequency oscillator to change the pitch up and down over time, and then explore the various parameters and the effect that they have on the sound. First, insert the low-frequency oscillator into modulator slot number 1. Nitrous now provides you with an easy-to-understand graphical display that gives you a good idea of how this is going to affect the target parameter. Before it can do so, you need to link the modulator and the parameter by using the matrix. Using the drop-down menus, select the internal modulators option, and then Mod 1 LFO. On the other side, you select the target parameter, which in this case will be the operator parameter and operator slot 1, which is where you will find the pitch shifter effect. At the moment, the low-frequency oscillator will not affect the pitch at all because its sensitivity is set to 0. This is what the untreated sound sounds like, to give you more of a point of reference. It is just a simple sine wave generated by a virtual analog synthesizer. The reason for this choice is that it will give you the clearest audible indication of the processing that is going on. Now listen to what happens as I increase the sensitivity up to the maximum 100%. You can clearly hear the pitch change over time. The rate at which this modulation occurs is determined by 2 controls, mode and rate. The mode can be switched between a tempo editing and a song position, or it can be left to cycle on its own using a frequency of up to 30 Hz or 30 cycles per second. At the moment, the low-frequency oscillator is following the sine wave form. Although this can be changed to square, triangle, saw, or sample and hold waveforms. The depth control acts similar to the sensitivity control in the matrix, allowing you to tame the effect if the results are too extreme. The smooth and tilt controls can be used to deform the waveform in specific ways. As the smooth control is increased, it changes the slopes of the curves or angles that are used in the waveforms. The tilt control changes the waveform by changing the bias between the first and second half of the wave. This can have a very strong effect on how the sound is manipulated. Lastly, the offset controls offer control on how the modulation is applied to the left and right channels independently. It changes the phase from the left and right waveforms. An example of how you'd use this is that you could have the left side rise as the right side lowers, and vice versa. This can be put to good use to produce some very interesting panning effects. Using the same patch that we looked at, I can also use the low-frequency modulator to target the panning of the panner effect by using the second slot in the matrix. And that should give you a good idea of how the low-frequency operator works. In the next video, we'll have a look at some of the other operators that are available.